Good morning. I must say, after last night's party, I am very impressed that this many of you made it in for 9 o'clock. Good heavens. I think Hadi Hariri singing Eminem needs to become a staple of Kotlin Conf. So that needs to happen. That needs to happen every year. So good morning. I'm Daniel. About 25 years ago, who wasn't born 25 years ago? Yeah, oh, adorable. About 25 years ago, I was on IRC, which is like a Discord's great-granddad, and there was a Java channel, and there was a few guys who had escaped from a big corporate, and they were building a little IDE. They wanted to build a little IDE, and they would so the way they would release is they would just post a URL into the Java channel, okay? And that was IntelliJ. And you got really excited when they put a URL in there because that meant you now had extract method, right? Or rename field. And they were working so furiously on this thing. So I've been around, I've been around JetBrains since before it was JetBrains. I've been around IntelliJ from the very early days. This morning, I want to tell you about the guy who invited me onto the Java channel. So I go back a long way with this chap. I know a lot of programmers. I'm very lucky. I've worked with some brilliant, brilliant people in my 30-something years in industry. I want to tell you about the best one. Okay, and we go back a ways. One thing I want to mention before I start, because this is kind of where this talk came from, is he never went to college. Everyone talks about you need a degree and whatever. Or in fact, no, that's a lie. He went to college for 6 weeks. And 6 weeks in, he's like, is this it? This is rubbish. I'm going to go and get a job. So he went off and got a job instead. The other best programmer I know, who doesn't appear in this talk, did get a degree. He got a first-class honours degree in computing from Imperial College in London. So, honestly, that stuff shouldn't be a barrier, shouldn't matter. This is a talk in 3 parts, okay? So, and my goal with this talk is to give you some advice. If you are just setting out in your career, great, welcome. And hopefully this will give you something to guide you. If you're a long way into your career, hopefully there'll be something in here that will challenge you. There's certainly stuff in here that challenged me. So this is more of a kind of confessional, really, than a talk. So let me tell you about this chap. The first thing he does, probably better than anyone I know, is he gets the job done, right? Our job as programmers, as software people, is getting the job done. What do I mean by that? Well, he has the magical ability to just start. Okay, I really struggle with just starting. What I do is I procrastinate. I don't call it procrastinating, I call it research, right? So, I'm going to write something, well, I need to read the tutorials first. I need to gen up first. I need to educate myself first. He's like, let's go. But you don't know anything. He goes, that's fine, we'll figure it out. Yeah, I'm a smart kid, we'll work it out. And this is the thing, start anywhere, right? Start anywhere, because it doesn't actually matter, yeah? And seriously, anywhere. Because doing is researching, okay? And what happens is a very human thing. It's called kinesthetics. Kinesthetics is when you are interacting with something is when you learn best, okay? There used to be a theory that there's different styles of learner. Some people learn by looking at things, they're called visual learners. Some people learn by hearing things, they're called auditory learners. Some people learn by interacting with things, they're called kinesthetic learners. It turns out that's nonsense and we're all kinesthetic learners, right? We all learn better when we're playing with the thing. Okay, some of us like to hear things or see things. We definitely have a bias one way or the other, but we are all kinesthetic. And this is hard. No, you don't know. Okay, knowing that you don't know, I find I like to call myself a perfectionist. Perfectionist is a euphemism for having a massive ego. Right? anyone here who thinks of themselves as a perfectionist, you just have a massive ego too. And you don't like things that puncture your ego, like being wrong. Okay? So if you just get into a mindset of being continually wrong, right? It doesn't have to be right or even good. Whatever you're doing now is a sketch. Even if you think it's the final thing, it's a sketch. Everything will change, okay? So just getting on with it is quite a fun thing to do. And then iterate wildly. This is my one Smith's reference for any old people. Iterate wildly. So what does this mean? Just try stuff and try stuff and try stuff, yeah? This idea of going stoplight to stoplight. So in the US, they have gridded cities. So the cities are like a nice, neat grid like this. And what happens is in the rush hour, like morning and evening, they fix the flow so that all the downtown traffic goes all through green lights all the way down, and in the evening, it all comes back up. If you're trying to go cross town, all the lights are red, okay? So you've got two choices. One is you can sit there till all the lights go green, right? Pretty boring. Or you just go stoplight, 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 knowing that it's going to take you a long time and knowing that that's okay. And again, this when it starts out, it's frustrating. But when you kind of start to think like that, and that's just how we do stuff, you will get there much faster than the people waiting for all the lights to go green. Okay? So, there is no best time to start, so start now. Yeah? Start now and figure out your way. Go from stoplight to stoplight. And it's this cycle of try, fail, learn, repeat. And it's that second one that really sucks. Right? Because you go try for, what? That seems wasteful. What I should do is know. If I go in knowing, then I won't fail, right? My ego again, yeah? No, keep on iterating. Try, fail, learn, repeat. So just start. I've been trying to learn how to do this. Like I said, I've known this guy a very long time. I'm probably, the last 15 years or so of my career has been trying to explain to people how to do this. Yeah, and it's partly therapy. It's partly trying to convince myself to do this as well. I still struggle with this. I know this is a sensible way to do things. I still struggle with it. So here's the next thing that he does that took me far too long to figure out. Okay, you're building a product. Anyone who is computering in any way in this room, which I suspect is everybody in this room, right, is building a product. What does that mean? It means that your emotional investment, the thing you care about, should be the outcome, not the code. The code is the means to the end. The less code you can use to get to the outcome, the better. If you can solve the outcome with no code, you win at code. Okay, the way to win at programming is not to do any programming. Okay, so code is the cost of getting there, right? And so what I found, that the most highly, I've been very lucky, I've been in some very, very highly effective teams. What I noticed is they managed to hold two conflicting ideas in their head at the same time, which I've also been assured is impossible. So the two conflicting ideas they hold in their head are this: I will write the best code I can. I'm not going to write rubbish code. No one wants rubbish code. I will write the best code I can. I will have no emotional attachment to my code. I heard the murmur. Everyone's going, how can you have no emotional attachment to something you've invested in? You're investing in the product. You're trying to build the best product you can by writing the best software, the most appropriate software for that product, but you're building a product. You're investing in the product. Study the domain. This should go without saying, but often we don't. Often we get institutionalized. We get this kind of learned helplessness of what they call the feature factory. So you just get work to, stories, features, however you batch up work, to turn into code. And we think of it like that. My plea, my suggestion to you, pan back a bit, right? Why am I writing this code? another mea culpa. If you were around in 2007, 2008, the financial world collapsed. Okay? Turned out a bunch of very dodgy traders had been selling some very dodgy mortgages, and the whole house of cards came down. I was writing some of the software that supported that. Go team. Right? I didn't know. There was a thing called a CDO, a collateralized debt obligation. Okay, and a CDO is like the financial vehicle of choice for the financial meltdown. Okay, I was writing systems that made CDO trading faster. I didn't know what a CDO was. Didn't educate myself. Yeah, I possibly wouldn't have taken that gig. Who knows? Yeah. I was also at Lehman Brothers when they collapsed, so I'm just not going to say any more about that. And this is something that he does, and that I've learned to do. I really enjoy doing this, actually. And again, I appreciate many of you are working in these huge, complicated organizations where you're often several steps removed from the people using your software. Even so, try to look at your users. There was, in the UK, there was another, technology fail. It's about 15 years ago now. In NHS, in the health service. And they spent something like £18 billion to build a very small database. Or rather, that's all they got out of it. It was just, the whole thing was a complete disaster. And they said, we're never going to do this again. They did it again. Right, they're never going to do this again. And they set up an organization called Government Digital Services, GDS, which is still going. Some very smart people. In fact, I think some people in this room have actually worked with them. And they take this stuff very seriously. Right, they have like design guides, all this kind of stuff. Go to have a look at the GDS. If you just Google or DuckDuckGo, now it's back, GDS team, you'll see they have wonderful, wonderful style guides and all this kind of stuff. In their office, which is in central London, they have a big sheet of paper, big sheet of butcher's paper on the window. And there's a hole cut in it, like a little letterbox. And there's an arrow, and it says your users. And you look through the gap, and you're looking down on just a bunch of people walking into Costa Coffee. Right? It's gorgeous, yeah? Watch your users, okay? What frustrates them? Because here's the thing, if you say to someone, what do you want to do with this system? How do you want to improve this system? They might have a laundry list of things they want. They might not know, right? They might not know. It's like, I'll know it when I see it. If you sit next to them for any length of time, at some point they'll go, what was that? What was what? Because you don't notice when you sigh, other people notice. You went, oh yeah, that's because, I'll tell you why, it's because every time I get to this part in this app, I have to copy this information from here into that screen, and it is just, it's so annoying. And then I usually get something wrong, and so now the address on that system is different from the address on that system. I'm like, why didn't you say something? Oh, it's just that's how it works. That's just how it works, right? Because everyone just thinks that's how it works. And then what do? You go, I can solve that. I can magically make that address already appear over here. Whoa. Can you? I'm a programmer. I can make a computer do anything, right? Wow. Yeah. So listen for that. It's some of the most powerful and effective user feedback you can get. So we've just started. We're building a product. This is something else I struggle with, solving for now. When I first met Eric Mayer, who is one of the most wonderful human beings I know and has a brain much bigger than practically anybody else I know, we got into an argument. Can I just suggest, don't get into an argument with Eric Mayer? This is my first piece of advice. We were arguing, and what we were arguing about was this. I was talking about this. I said, basically, we solve for now. We solve for the immediate case. Once we've done several, we kind of generalize. And he says, no. I'm not going to try and do his accent. He says, no. He says, this is not how science works. This is not how mathematics works. We solve the general case, and then we apply it. And we had this argument. And sometime later, actually, a mutual friend managed to kind of make peace. He said, yeah, here's the thing, right? Daniel, when you're writing software, you're writing business apps. And if you get something wrong, you can just change it tomorrow. Okay? Eric designs programming languages. Eric designed Haskell, right? He's one of the people who designed. He doesn't write Haskell, he wrote Haskell. He also wrote LINQ, L-I-N-Q, the query language at Microsoft. He's done some pretty interesting stuff. if you get something wrong in a programming language, I came up with the term change event horizon. How long does it take you to actually affect that change? My change event horizon is the next release, right? It might be days or weeks or maybe even hours. Programming language change release horizon could be like 25 years. There's still stuff in Java that says @deprecated that was @deprecated before any of you were born. It has been deprecated certainly your entire career, right? It's not going anywhere anytime soon. Yeah. So for most of us, for those of us who aren't designing programming languages, okay, solve for now. What does that mean? That means see what's really there. Okay. This is an icon from Font Awesome. It just looks like a pipe. Your brain is telling you it's a pipe. It's not. It's just some lines on a screen, right? Learn to see what's really there. At one point, my buddy wrote a Java web server. It's about 12 years ago. He said, what I need is a web server in Java. I'm like, mate, there's hundreds of web servers in Java, right? Why write another one? He said, no, there aren't. I said, no, there's no web servers. There's lots and lots of servlet containers, but there's no web servers. I thought about it, and he's right. All of these, Java web servers, they all have the entire, and most of, well, some of you might remember these dark, dark days of enterprise Java, this thing called a servlet, and a servlet had a life cycle, and the servlet life cycle has about 10 different methods that you have to implement in order to start it up and inflate it and do things, and then at the end of it, kind of pack it away again. And every single Java web server has all of this incredibly heavy bloat just baked in. Right? You think you're doing an HTTP request response. No, you're not. You're doing HTTP request, entire servlet lifecycle for a servlet that isn't even their response. So he sat there on the train, this train project, on his commute, and he took out the HTTP spec and he wrote it in Java. And it was an insanely performant little web server. Yeah. So see what's really there. He has the ability, as a chap called Oliver Wendell Holmes, who was an American judge. He says, I wouldn't give a fig for the simplicity this side of complexity. For the simplicity the other side of complexity, I would give anything. Right? This guy has the ability, and it still annoys me every time he does this. I'm looking at this thing, and I can see this problem, and I know how to solve it. I'm really smart. I'm really good at programming. I see this, and I'm going to go solve this. And just before I do, he says, yeah, but isn't it just that? And you go, I hate you. Because he then goes, poof, and all of this stuff goes away. I'm like, happened again. It happened again. Right? See what's really there. It is hard. This takes conditioning. This takes practice. And solve the real problem. So I was working with a finance, basically all my stories are finance companies. So I was working with a client a while back, and one of the discussions they were having was against the Java shop, which JSON library should we use? I was like, what do you mean? I said, well, we've got JSON flying around the place. We need a JSON library, and we're looking at the JSON libraries and trying to choose one. I said, so we looked at the JSON libraries, and of course, Maven, right? So that means that the JSON library comes in with 700 of its friends, yeah? And I said, so tell me about this JSON then. What are you sitting around? I said, we're serializing things, sending them across between systems. I went, how many things? How many things are you serializing? I hadn't really thought about it. Went away and found out how many things they were serializing. 9 things. They were serializing 9 things. I suggested that they have an interface called JSON serializable with a single method on it, serialized to JSON, that returns a string. And they went, oh, can we do that? And for each of the 9 classes, for each of the 9 objects they had, they implemented a single method that returned a string. What happens when the class changes? Change the string. Oh, yeah. Solve for what's really there. Solve the real problem. It might reduce your dependencies. Yeah. There's a wonderful little library at the moment called HTMX. HTMX is what HTML should have been. So instead of just having submit on forms and things, You can attach kind of posts and gets and whatever to anything. It's tiny. It's a tiny little thing. And when you put, there's some wonderful use cases on the HTMX website, or case studies rather. And one of them, they said, we got rid of 95% of our JavaScript dependencies. 95% of our dependencies by having this tiny little library. Solve for now. And strive for simplicity. This is really hard. Yeah, the simplicity, the other side of complexity. Write the README, and then do what I call embarrassment-driven refactoring. So I was handing over a system I'd written. It was like a little Heroku ripoff in Python that I'd written. And I was handing it over to my buddy because I was leaving the company, and I wrote the README. And there was like a couple of pages of stuff you had to do to stand this up. And as I read it, I was like, I can't give him that. I can't give him that. So I spent a couple of days just cleaning it up based on the README. And the README eventually said, install this thing, change that port. 2 steps. So I can give him that. I'm okay about that. Right? Write the README for what you've done. That is a reflection of how complicated you just made the world. Okay? Be kind to future you. So, okay. So this is about getting the job done. Now, in order to get the job done, we need to choose the right tool. And again, this is probably one of my biggest 180s that I've done in my big career. Where you're absolutely convinced of a thing, and then you become absolutely convinced of exactly the opposite thing. Okay? And this is the thing. You choose the right tool for the product. You choose the right tool for the thing you're building, not for the team. How many times have I heard, well, what does the team know? What is the team comfortable with? What technologies does the team like? Let's use those. Okay? Spoiler. Code outlasts teams. Data outlasts code. Data outlasts organizations. Right? Data will be there long after we're all dead. Right? And teams can learn. People can learn stuff. So again, one team, I joined the team after they made this decision. The tiny little team, another trading firm. And the 2 people, in fact. And they said, we're going to use Scala. This is long before, or a bit before Kotlin existed. Otherwise, they'd have said, we're going to use Kotlin. We're going to use Scala. Why are we going to use Scala? Well, we both know Java really well, but Java takes time to sketch in. Scala is a much easier language to just sketch code in. But we don't know Java. We don't know Scala. Well, we'll learn Scala. So he figured that he could learn, and again, solve what's really there. Not learning Scala, because it's a huge, ugly, slow, don't get me started on Scala. Not learning Scala, learning just enough Scala that I can sketch code. It turns out that's quite quick. So they learned Scala and built this thing in Scala. Okay, neither of them had ever used Scala. I joined the team, I had used Scala, and I was like, what the heck have you written here? This is horrible code. They went, yeah, but it's very fast. We got there really quickly. I couldn't believe that I became the good Scala programmer on the team. Yeah, so what this means, when you start choosing the technology, the tools for the solution space, you're minimizing the cognitive difference between the actual solution, like the abstract solution in your head, and the code you wrote. Okay? So a chap called Rich Hickey also designs languages in the Java space. He has a Lisp. Rich Hickey comes up with this lovely talk. I've made you a nice little simple URL there. Simple made easy. And he's talking about the difference between easy, which is stuff that springs to mind, and simple, which is the smallest thing, the Occam's razor thing you can do in a situation. And the thing is, your mind changes. Your learning changes all the time, okay? So you are a point in time. It's a lovely Bruce Lee quote, be like water. So water is, if you put water in a cup, it's the shape of a cup. If you put water in a bowl, it's the shape of a bowl, okay? Whatever is the right technology, the right choice for the situation you're in, be like water around that. Trust yourselves that you can learn these things, okay? And things change. The right tool may change, okay? What the definition of right might change. So what we want to do, Kent Beck has this lovely saying, make the change easy, then make the easy change. Okay, if you haven't come across this, this is when he talks about like refactoring and test-driven development and whatever else. He says, I want to make this change, it's really hard, change the systems so the change I want to make is easy, then do that. So I want to explore this, just make the easy change idea. How do we make change easy? The most powerful tool we have in our tool bag for making change easy is small things. Build small things that talk to each other. Okay? Optimize for composability. Optimize for small things. I've been talking about this pattern for a long time. I've failed to write a book for 12 years. I'm really good at failing to write books. I'm now failing to write 3 books. I talk about spike and stabilize. The idea with spike and stabilize is you treat everything like a spike. Everything is a hack. Everything's an experiment. And then what happens is it doesn't mean you're going to write bad code. Remember, I'll write the best code I can, but suitable for now. Yeah, so I solve for now. And then it turns out most of that code won't ever get used or won't ever be useful or won't ever earn its place in the product or whatever, and I'll get rid of it. And I don't mind getting rid of it because I didn't overinvest in it. Yeah? The code that lasts, I'm going to stabilize that code. And here's a thing. Right? Here's a dirty secret. If you take code that you hacked and after a while you say, do you know what, actually we're going to hang on to this code, I should write the tests for it that I should have written at the time, and you start massaging this code to make it testable, right? Make the change easy, it ends up looking a lot like you test drove it in the first place. Don't tell anyone, right? Because they'll come along and go, oh, that's very good, that's test-driven code. And you go, yes, yes, it is, yes. No, I just slammed it out because I was trying stuff, and then I invested in it. But you end up, it's like throwing darts at a wall and then drawing the rings around them. You get a lot of bullseyes, right? It's a great way to win at stuff. And it also means then that you have these, classic reduce, reuse, recycle strategies to hand. Reduce, it's easy to, once something gets a bit bigger than you'd like, it doesn't quite fit in your head anymore, it's easy to decompose that into smaller pieces. You can reuse stuff. You can say, right, I want to use this in more than one place. I can turn it into a nice API. I can make those choices, but I make those choices based on demand, not based on assumption. Yeah. And if it turns out that we did this again and again and again with this Scala code base, after about, I'm going to say 6 months, I think there was no Scala. We had replaced all of it, but not all at once, just as we needed to. As it turned out that this thing needs to be faster or different or just to make more sense. And also that we found out at the time, again, it's going back a ways, that the Scala toolchain, A, is really slow. We know this, right? But it turns out the Scala core libraries were buggy as heck. That's unfortunate. Right? So this is in a trading environment, very high frequency, fire hose of data. They have a thing called a concurrent hash map. And the concurrent hash map failed under high concurrency. Just started emitting nulls. And I was like, what? We're getting nulls. Where are these nulls coming? Oh, they're coming out the core library. And then we looked and there was this open bug for like 2 years that your concurrent hash map doesn't. Yeah, they said, but Clojure's got some really good collections, so we're going to use those. But, right, when? Oh, we don't know. There's no point fixing this if we're going to get rid of it. I was like, oh my goodness. So yeah, reduce, recycle. Right? If you need to rewrite a chunk, you can be confident that you're just rewriting that chunk. Okay? And then, you know what? That's how all code works. You suddenly don't need a different strategy for whether it's a spike or whether it's production code, how we're going to do that stuff. This is simply how we write code. We sketch. I use tests, I think of them as guides, right? So I use example-guided development, I call it, instead of test-driven, because they're not tests to me. They're examples that guide the design. And I use these little examples to guide me, not because I'm some kind of purist, just because it helps me think, right? Because otherwise I go off in all kinds of different directions. And again, it helps keep me focused. Solve the real problem, solve what's really there. Cupid, this is my second book I haven't written, is an acronym I came up with a few years ago. Of characteristics, if you like, properties of software that makes you smile. That you crack open a code base and you go, oh, I could work here. I don't find this intimidating. I find this easy to navigate. Cupid.dev has its own website. Please take a look. And instead of thinking of architecture as, the thing that locks you in, Think of architecture in terms of options. Yeah? So architecture is choices. And each of those options has what's called a cost of reversal. How much will it cost me for this to have been the wrong decision? And what we want to find is those architecture choices that make reversing less expensive, because then we can do lots of things. Right? Linus Pauling, the physicist, says the way to have good ideas is to have a lot of ideas. Right? The way to write good products is to write a lot of code and chuck most of it away. And someone goes, wow, you've really got some great code in this product. And you go, yeah, well, I'm just a great programmer. I'm not. It's all a lie. All the rubbish is over here. You won't see any of it. We won an award once. I was on a team that won an award for, this is it's far enough I can tell you now, it was BP. It's BP, we're writing a big global trading system for them. And we won their software quality award. And it was the first time an external provider had won this coveted quality award. And it turned out that we won this award because there was a 6-week UAT phase at the end, during which they found 0 bugs, and that had never happened. Right? Wow, this team's writing really amazing software. No, it's not. It's writing the same software as everyone else, but we had the testers in the team, and they were testing continually because that's just how we worked. And we had thousands of bugs. I know we had thousands of bugs because I looked, right? But we'd found them on the way through. And it turns out the same team of testers who'd been in the team the whole time spent this 6 weeks. And we said to them, we're not going to need 6 weeks. Yes, you are. Yes, you are. So you're going to pay the entire team to be in the building for 6 weeks you won't be doing nothing. You'll be fixing bugs. Okay. So there were 5 meeting rooms in the building. There was a pub just down the road we used to call meeting room 6. Where's the team? Meeting room 6. Okay. We spent 6 weeks in meeting room 6 and won an award for it. Okay, so that's how you win at software, right? I know this is a Kotlin conference, right? But I suspect many people in this room use many technologies, of which Kotlin is probably their favorite. I don't know, certainly up there. It's one of my favorites. I'm such a fan of Kotlin. What I mean by this is learn lots of languages. Why do you learn lots of languages? You learn them so that they make you think differently. If your background is in OO, learn a functional language. Not necessarily to write functional code, but so you can also think in that model. And what you'll find is there isn't a code base that is, or a problem that is OO, best suited to OO, or a problem that's best suited to functional programming, or best suited to vector programming, which is going to become a lot more relevant soon. You're going to find that aspects of every problem have elements of each. And if you can, again, it's the simple rather than the easy, if you can use the right tool in the right situation within that context, you are winning. Okay? The cognitive distance between the code you wrote and the problem you're solving is much, much shorter. Right? So I'm a massive fan of Advent of Code. Who here does Advent of Code? Yeah, oh yeah, little hands. Eric Vessel. I don't know anything about Eric Vessel other than he does Advent of Code. So this guy, every year, and he has a day job as well, right? Every year he puts together, for the whole of, December 1st through 25th, he puts together a puzzle. And it gets released every day at the same time. And there's a leaderboard. I don't do the leaderboard. I'm not a speed programmer. I don't really do that. You can learn to do that. But the puzzle's in 2 parts. And the genius thing about Advent of Code is this. The first part is like you solve a thing. You write some code and you solve a thing. The second part almost always breaks the solution to your first thing. So one of them, I don't know, one year it was Game of Life, right? So Game of Life, and you're, Game of Life is going to be like a square little matrix and it's going to have some things in it. And then the second part is this Game of Life is on, 100 million square grid. And suddenly my array doesn't work. And now I have to start thinking in terms of sparse arrays. And I need completely different data structures to solve the massive problem than I did the little problem. And it causes me to think. I've used Advent of Code to learn Rust, which is a lot like being told off by a borrow checker. I've learned Go in Advent of Code. Kotlin's always my happy place in that. So last year, I think it was last year, I started in Kotlin. I thought, this is fun. I just wanted to solve the puzzles. I thought, no, I'm going to switch to Go because I don't like myself. No, I'm going to switch to Go to see, because the one thing, Go is a very simple language. It has no functional affordances at all, right? No map, no reduce, no fold, no any of that stuff. Everything's a for loop. And my hypothesis was, I bet it's going to be like that in Go and like that in Kotlin. And so I went back and solved the same days in Go. Obviously, you know the solution now, but you solve it differently. And it turned out, to my surprise, it was roughly the same amount of Kotlin code and Go code, just different code. Yeah. So that surprised me. And so now I know how to, but also in Go has wonderful support for coroutines. I know Kotlin's now getting much better support. Go has what are called Go routines baked into the language from like version 1. And so you tend to use channels and send things along them and all that just because it's easier to reason about. You can make smaller lumps. So be a polyglot. The more languages, the more paradigms, the more styles of programming you can explore, the more options you have, the more likely you are to find something that fits that little problem. Yeah. Joe Armstrong, the late wonderful Joe Armstrong, who designed the Erlang language, he was talking about object-oriented programming. He said, the thing is you want the banana and you get the whole gorilla. And in JavaScript, it's attached to a jungle. Right? And this is the thing, when you have these sort of channels and messages type languages, you just end up writing bananas. Be full stack. I put full stack in little air bunnies. Being full stack is sure, if you're mostly a back-end developer, at least be able to write a decent looking web page, right? At least put a front end on it that isn't ugly, that looks reasonable, that someone wouldn't go, oh, good heavens, unless it's a ploy. So we have one guy in a team I was in with my buddy, and he used to make pages, because it was a web app, he used to make pages so ugly that someone would have to come and clean them up. Right? And that was his ploy. I'm not going to try and get good at this. I'm going to make really ugly pages. And then someone in the team would go, I can't live with that. I have to make that look better. And that was how things got better. What makes a great service API? What makes a great distributed architecture? Again, if we can have these thoughts, if we can have these tools to hand, then it means we can reason better about things. And then be really full stack. Right? Get outside of the computer. So this chap, he's built hardware. Actually, at one point, he built a product that was ended up in the Apple stores, And he went to China and sourced the whole thing, right? He's quite an interesting character. But don't just think about, I need to solve this with software. What if you can change the process itself? Simplify that. Make that go away. What if you can build a thing? We used to have trouble getting everyone synced up with the stand-ups. People were just kind of drifting at different times. And so he took a that was easy button, that was easy, beep. And he put a little bit of stuff in the that was easy button. And when you hit the that was easy button, everyone got an SMS. Stand-up time. Oh, off I go. Took a little bit of time. But again, it wasn't like, oh, how can we solve this? It was, how do we solve this properly? Sometimes just change the whole problem. We need to solve this thing. Why? Why do we need to solve this thing? Why don't we do it differently? When we worked at a consultancy together and we were bidding there was a bank wanted us to do some work, and you do what's called an RFP, request for proposal, which is usually 20 or 30 pages of very dry text. He said, well, I'm not going to do that. I'm going to write software. I'm going to write them a prototype of the thing they want. If I'm going to spend a week doing this, I'll spend a week writing code rather than writing text. Right? Okay. And so we worked in half-day iterations, half-day sprints, whatever. And every morning, we're like, what do we want to see by lunchtime? Every afternoon, what do we want to see by the end of the day? And over about a week, they went boom, 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 boom. There's 10 of these little sprints. And then they had the showcase with the client. And of course, there's two competitors, very big, serious suit-type people. Slides, and everyone's nodding very sagely like this. And then we went up and just plugged in the app. And we said, well, this is sort of what you're looking for, right? And they went, yeah, that's pretty. When could we have that? He goes, oh, no, that's real. That runs. You can plug that into your data right now. By the way, and this was the payoff. This was really cool. By the way, I've got it on a load of thumb drives here. That was that RFP. We won the work. All right? So Okay, so we've looked at understanding the problem, getting started. We've looked at choosing the right tools. There's human beings involved. There's human beings involved in software. It's a very, there's a lovely word that's become much more prevalent in the last, I'd say 7, 8 years of socio-technical systems. We talk about socio-technical systems, humans and computing doing stuff. Nothing is new, right? In the 1950s and 1960s, a guy called Taiki Ono, who was working at Toyota, he coined this term automation. So automation was automation with a human touch. Automation not to replace people, but to augment people, to make it easier to do work. Our job is automation. Our job is making it easier to do work. No trader wants to use a trading system. They want to trade. The trading system is between them and trading. No one online wants to go through a retail website. They want a t-shirt, right? Everything between wanting a t-shirt and having a t-shirt is just friction, right? It's just grit, okay? So how do we make that easy? Amazon, again, way back in the mist of time, invented the one-click purchase. Buy it now. Someone had to invent that, right? That looks cool. Boom. Tomorrow, sometimes today, right? Sometimes 2 hours from now. Yeah. But that took all of the grit out of the purchasing process. They did quite well. Amazon, doing all right. So let's carry about the team. Let's start with the others, the folks in your team. Think about caring about other people. One of the things that my buddy does, and I do, I'm a real sucker for this, right? Find joy. Not just help other people or feel like it's an obligation to help other people. Find joy in helping other people. One of my favorite things is pairing with someone and they go, ah! And you go, yes. Sometimes I go, yes, out loud. It's a bit embarrassing, but yeah, yes. Yeah, oh, right. There's a wonderful XKCD about, they call it 10,000, he calls it 10,000 people. And he does some really simple maths. He's ex-NASA. He's really good at kind of coming up with maths for things. And it's about the things everybody knows. I thought, everybody knew that. Mentos in Diet Coke. I thought everyone knew that. And he does this theory, just based in the US, the US population, all the things you're likely to learn in a day, the number of people in the US, the average age, and it's quite clever. He says, on average, 10,000 people a day will learn a thing that everybody knows, right? And so so the comic strip goes like this. He says, rather than going, I thought everybody knew that, you go, cool, you're one of today's lucky 10,000, right? And I've developed that. So if I say something, someone's completely blank, let's use a MapReduce here, and they go, oh, cool, I get to be the person who tells you about MapReduce. And now they feel a lot less stupid, and you get to teach them a thing, right? Everybody wins, okay? So take absolute joy, right? And I found, again, like putting this talk together, taught me stuff. Teaching is a great way to learn things. It's a really, really good way to learn things. About 100 years ago, I used to do martial arts, jiu-jitsu, and I did an instructor's course. And they teach you 2 things on the instructor's course. This is probably, 25 years ago, maybe 30 years, that have stuck with me the whole time, right? Because it's transferable. The first thing they said in the instructor's course is this: you cannot teach anyone jitsu. What am I here for then, right? You cannot teach anyone jitsu. You can create an environment in which they can learn jitsu, but then it's up to them, right? Our job is to create an environment in which, yeah? And the second thing they said, which was really powerful, is don't over-present yourself. No one's there to see you, they're there to learn jitsu. Oh, yeah. And I think it's the only martial art, certainly the only martial art I've come across. You have to be an instructor, you have to run a club for like a couple of years before you can do your black belt. So you have to teach before you get to grade, right? A lot of martial arts, you become a black belt now, I'm a black belt now, and I'm going to go in and punch people, right? And jitsu is like the opposite of that. It's like, I'm going to learn humility, I'm going to learn teaching, I'm going to learn how to share this thing, then I qualify to grade. Yeah, kind of cool. Send the team home. This shouldn't need saying. This shouldn't need saying. Sustainability, okay? People have stuff, yeah? People have lives, people have families, younger people have interests and stuff that don't involve families. I heard a brilliant thing. Once you have kids, this is for the men. Once you have kids, you no longer have friends. Your kids have friends, they have mums, and they have husbands. Okay? That's your friend. I'm like, don't be silly. It's like, yes, it's true. Send the team home. Right? A rested team is way more effective. Okay? Nothing beats a good. Well, I read somewhere, the best debugger in the world is a good night's sleep. Yeah? Send the team home and model it yourself. Right? People working late isn't a sign of dedication or a sign of commitment. It's a sign of poor management, poor planning. Really? You couldn't get this work done in a regular workday? Would do different things then. Either do less stuff or do the stuff you're doing better, right? And be kind. Be kind. Assume everyone's doing their best. Virginia Satir was the first family therapist. So before Virginia Satir, you had child psychologists, and you take your child, because the idea was your child's broken, and you take your broken child to the psychologist, and they'll fix them, right? And then they send them on their way. And Virginia Satir, she said, no. The child's behavior is a presenting symptom of the family. I need to work with the family to solve the behavior, right? It's like having black smoke coming out the back of a car. You don't work on the exhaust. That's just where the smoke is coming out of. Right? What do? Plug the exhaust? No, you figure out why there's black smoke coming out in the car, right? And so she accidentally invented the field of family therapy. And she had this wonderful phrase. She said, everyone's trying to help. It's called the principle of positive intent. Everyone's trying to help. This is pretty powerful because it means this. It means if someone is doing something that you think is just wrong, right? Is just weird or broken or something. I've been in organizations where you see people actively sabotaging things and you're like, you mentalist. What's true for them? What's true for them such that they think this is helping, right? And it gives you empathy. It lets you get inside their head. Yeah? And you suddenly realize they're not trying to sabotage this thing. They're trying to save the organization they work in. They're convinced that this is bad for the organization or bad for the team or bad for whatever. And they can't stop it. They don't have the authority to stop it. So they're sure as hell going to try and slow it down. Yeah? They're going to try and make it fail. And sometimes they're right. Sometimes it's exactly the wrong thing for the organization. I'm looking at you, Safe, right? Sometimes it's just don't do that, yeah? And build psychological safety. Psychological safety is one of these phrases that's been bandied around a lot. Please, please, please go and read Amy Edmondson, Professor Amy Edmondson's brilliant, brilliant book, Fearless Organizations, okay? But she coined the term, actually it's a great story. So psychological safety is an academic thing that happened about 20 years ago. And it's based on a fail. And the reason it became popular was based on another fail. Right? So the original fail was this. She's a PhD researcher in behavioral psychology, and she was convinced that high-performing teams make fewer errors. Seems a sensible thing to say, right? If you're a high-performing team, you mess up less. So she said, I'm going to go prove this, because that's how you get a PhD. So she went off, her and her research buddy went off into a bunch of hospitals in the US, and they looked at surgical teams. And surgical teams are a great case study, because they tend to go around as a team. You know, the surgeon has their anaesthetists and their nurses, and they go around as a gang. And she was looking at patient outcomes and the amount of errors that get reported, because there's like a regulatory thing, you have to report errors. And what she found was exactly the opposite of what she expected to find. The teams with the highest success rates also reported the most errors. And she's like, this doesn't make any sense. And then she had this moment of insight. She went, what if all the surgical teams have about the same number of errors, but the high-performing teams report them, right? What if they're the ones that report them and the low-performing teams just shush everything up? And this is where she came up with the idea of psychological safety. She calls it interpersonal risk. Do you feel safe taking interpersonal risks with people who are your work colleagues, right? It's a team scale thing. There's no such thing as a psychologically safe organization. It's a team construct. Within a team, there are basically three dimensions, if you like, three levers. The first is this: do you feel safe saying, I don't know? Right? I don't know is either, brilliant, this person wants to learn something, right? Or, well, you're an idiot, right? So if you say, I don't know, do people think you're an idiot, or do they think you're keen to learn, right? The second thing is, I need help, right? I need help is you're incompetent, right? Or you're collaborating, yeah? And again, one of those is true. And the third one is, I disagree, right? I disagree is you're a troublemaker, or you're trying to improve things. So if you're in a team where I don't know is considered brilliant, well, let's teach you. You're one of today's lucky 10,000, right? I need help. Fantastic. Let's pair on that, right? I disagree. Whoa, cool. Okay, why? Right, let's unpack that. So this is what psychological safety is. It's not feeling safe. It's not feeling comfortable, right? Often, psychologically safe teams are quite uncomfortable places because you're continually challenging people and being challenged. It's that massive ego thing again, right? There's safe teams and there's comfortable teams, and there's a lot of difference between those. Care about staying current, okay? It's so easy to get tunnel vision with your thing. Join communities. Be a net contributor to your communities. Don't just be a long-time listener, right? And find people who are going to challenge you. Throw the net wide. Don't just join the local Kotlin meetup. Join a bunch of other things. Get involved in other groups. Get involved in the kind of communities that will make you think differently, yeah? And try new things. Try new things. Retain a healthy skepticism, right? Especially about, I don't know, whatever this week's thing is, yeah? Stuff, right? AI, I'm sure there are elements of, and it's not artificial intelligence. There is no intelligence there. There's an awful lot of degree level stats going on, right? But not a huge amount of intelligence. There are enormous, powerful applications of machine learning and large language models. If you were in Eric's talk yesterday, you know, some of the ways he's thinking about consuming this, and that the LLMs are the CPUs of a future operating system, right? That's exciting, yeah? Plugging AI into your, you know, restaurant booking or whatever is just daft, okay? And practice. There is no substitute for practice. There is no innate programming gift. I really upset someone once. I was like, wow, we were looking at some code and he was able to navigate this code. I was like, man, you've really got just an ability to do this. And it turns out, I thought I was complimenting him. He was quite wounded. He's like, no, I work really hard at being good at this. I was like, oh yeah. And again, that ego, be prepared to be rubbish at new things. And finally, care about yourself. Right? If you are unresourceful, if you are burnt out, you are no use to anybody, okay? Have interests outside of programming. Do stuff, right? Have a sport. Do something physical. We're all sitting behind a desk all day like this. Do something physical, right? There's a guy called Yves Van Wiel. He's Belgian, and I've just pronounced his name really badly. And he has a walking desk. So, you know, a lot of people have standing sit-stand desks, right? He has a walking machine under his desk. He walks about 20 kilometers a day at his desk. Right? It's pretty cool. Yeah, he's very fit. And if you don't know what you like, try loads of things. You might surprise yourself. I discovered in my 40s that I like running. It just seemed like a really pointless thing to me, but it turns out I really like just going for a run. It's nice, right? Go home on time, right? Model that for the team. Remember that good night's sleep, yeah? Lovely phrase, who will remember you working late? It's not the people in your office, it's the people in your home, yeah? And be kind to yourself. You've got this. I believe in you. Yeah? It's going to be okay. A lovely chap called Dan Bodart has his blog, his subtitle on his blog, Yesterday I Was Wrong, is the title of his blog. I love that. Because you write these things and you go, oh no, but yesterday I was wrong. I know more now. Of course, today's yesterday, right? So today you're wrong too. So yeah, Get the job done. That's what we're here for. We're here to get the job done. We're here to create those outcomes for the people who are depending on us, right? We're building a product. If you write internal software for people, if you write platform tools for people, it's still a product. There is still usability. There is still user experience, okay? Choose the right tool. The way to choose the right tool is to know lots of tools. If you only know hammers, then the right tool is always a hammer, yeah? And care about the team, right? Care about the people around you. Care about yourself, okay? Above all, be kind. And please, please, enjoy the rest of your day. Enjoy the rest of the conference. Thank you for listening to me. And I'm supposed to put that up. So, thank you.